We are doing a little bit of time traveling really quick. I had to split this up into two different videos. But we have so far ended off with finding the surface area of this weird, it kind of looks like an ice cream cone with ice cream on top of it. We have not yet found, though, the volume of it. So I do like to kind of divide these problems into two. Surface area seemed like it was on that side. Let's go ahead and do the volume now on this side. Volumes are usually easier. We have number 1 and number 2 for our shapes. Find the volumes of each individually and simply add them together. So let's start with the volume of the hemisphere for problem number 1. That volume for a hemisphere we have from our formula as 2/3 pi r cubed. We do know our radius, so we can plug this in right away. 6 cubed. And then again, we can just plug and chug this in there. So let's see, I need a calculator for this myself. 6 cubed should give me 216. I'm going to multiply that by 2, divide that by 3. You should end up with an answer here of 144 pi for just the volume of this hemisphere. We are probably going to need to add that to the volume of the cone that we also have. And that cone, if we remember, is your area of your base times your height divided by 3. This time we know that the base is pi r squared, though, since it is a circle. Plug some of our numbers in. Radius of 6. Height of this shape is something that we don't necessarily have, though. We are missing that. And when you come back to this shape, remember the height is from the center of that base to the very tip top of what we see here. So we're going to have to do a little bit of math. And this is not like a Pythagorean triple at all, because you'll see that I have this right triangle to work with. That means I have my side over here that I can consider A, B, and C. I have B as 6. I have C as this 2 square root 34. I just want to remind you how this process works really quick, so especially when we're squaring square roots. If I have A squared, that's the height. B squared should be 6 squared. My hypotenuse is going to be the 2 square root 34 squared. Starting off, 6 squared gives you a nice 36, but when we get to this portion of it, remember that you treat these kind of individually. You square the number that's on the outside, and you square the number that's on the inside as well. 2 squared should give me 4. The square root of 34 squared, squaring something and square rooting something, undo each other. We actually just end up with what is inside the square root symbol there. So you actually find out that your A squared is, you got 36 here. You've got 136 on this side. Subtract off your 36. You find out that your A value is a very nice number of just 10. So that allows us to now use the height of this shape in our formula. Plug in that number 10. You should get yourself a nice final answer for this one of, let's see what we got here. 6 squared is 36. 12, you get 120 pi. These are the two values that we have to add together, the hemisphere and the cone. If I find out my final answer, the volume is just 144 pi plus 120 pi. That gives me 164 pi. Be careful with units. We have cubic units simply because we are in 3-dimensional space at this point. There are 2 other problems. I'm probably going to skip number 6 just for the sake of time. This one's a fun one, though. It is a weird looking shape where this is actually like a dimple, if you think of it that way, inside of the cylinder. So the surface area, I'll at least write the formulas for these things that we would use. The surface area that you have, we would probably want the hemisphere's surface area. So we'd say find the surface area of the hemisphere. We would need the lateral area of the cone. That's the sides of the cone. We would also probably need, though, the base of the cone as well. So those three added together should give you that total surface area. The circle on top is not there because that's where the dimple kind of is as well. And then for your volume, what we would probably do is we'd find the volume of the cylinder, and we would subtract out the volume of that hemisphere. And that's the big thing of the unit is it's usually find the largest shape and take out the smaller shape that's inside of it. I'll just say volume of hemi there. Try that on your own if you want to. If not, I don't think a problem like that's going to pop up too much for us. But let's look at number 7, the last one of the day. This is another one that we can find all of the formulas for surface area and the volume of it. For the surface area, let's take a look at the shapes that we have. Shape number 1 seems to be a cone. Shape number 2 seems to be a cylinder. And shape number 3 seems to be a hemisphere. So we've got our work cut out for us on this one. Let's try a slightly different approach to this one just so I can show you maybe a little bit faster way of doing it. Let's go ahead and break this down. I don't have much room vertically, so we're going to do surface area of everything first. Let's start with this. I probably, if I look at this cone, I don't think I can touch this circle. So we are looking solely at the lateral area of the cone, the sides of the cone. If I look at the cylinder, very similarly, I cannot touch the top or the bottom of that cylinder. They're both covered up. I simply need the lateral area of my cylinder. And then the last one that we have is technically just the entire hemisphere that I have. Again, though, be careful. I can't touch this little guy here. So we kind of consider that as the lateral area of the hemisphere. Individually, we've got some formulas we can plug into this one. Lateral area of the cone is your perimeter. In this case, it's pi r squared for the circumference, times that slant height. Ooh, I don't think we do have, no, we don't have the slant height. Let me show you where it is, though. So this measurement here is what we have for our height of 4 centimeters. I believe we know this distance right here is half of 6. That means that we have a very nice 3, 4, 5 triangle for our slant height. So we do end up with that L for slant height here. Lateral area of the cylinder is our, oh man, I did that very wrong, guys. Start over, my bad. I used the wrong circle formula. Your circumference is actually 2 pi r, not pi r squared. So that's the distance around it. Slant height, we'll use as L. For the cylinder, we're going to use the perimeter of a circle again, which is the circumference, or 2 pi r. We're going to multiply that by the height of that particular cylinder. And for your hemisphere, we've got that formula for the hemisphere that is 2 pi r squared. Remember, it would be 3 pi r squared if we did include this circle, but because that circle is not touchable, we took out one of the pi r squareds, leaves us with just 2. We can plug and chug numbers now. 2 pi radius slant height, 2 pi radius height of the cylinder, which is 16. Nope, it's not. We've got a distance here of 3, so we're going to have to calculate this. That means that this measurement right here probably has to be 9 centimeters to get that full distance of 16 all the way across. So we've got a measurement of just 9 for that height. And then the cylinder, or the hemisphere itself, radius is 3 again, and we're just going to square that sucker. Plug and chug your numbers. I end up with 15. I get 30 pi for this one. I end up with 2754 pi for this one, and I get 18 pi there. Ladies and gentlemen, I believe that is a grand total of 69 pi lied so much there. That's 87. That was bad math there. 87. That's more than 87. Darn it, guys. I made another boo-boo. The boo-boo that I made was right here. And if you guys were in class, I'm hoping you'd be yelling at me right now. The lateral area for a cone does not include that number 2 there. It does not then include the number 2 here, which means this should actually only be 15 pi. I think that looks much better for the final solution that we needed. Grand total here, 87 pi centimeters squared. So you can see that's a pretty interesting problem. Lots of work when it comes to surface areas. When it comes to volume, life's a little bit easier. Shape number 1, if I have this, if we're going to write this out, I need the volume of a cone. I need to add the volume of a cylinder, and I need to add the volume of a hemisphere. All 3 of those have their unique formulas. For us, we will use, this one is your base, which is pi r squared, times your height, divided by 3. That's the volume of a cone. Volume of a cylinder is your base, pi r squared, times the height. And for your hemisphere, we have ourselves 2/3 pi r cubed. Luckily, again, we do have all the numbers that we're going to punch and plug into this. So let's go ahead and do that real quick. Radius of your cone was 3. Height of your cone was 4. Radius of your cylinder was 3 again. Height of your cylinder was 9. And last but not least, the radius of that final hemisphere was also 3. I'm just going to rewrite this up here for you guys. Doing some math, 3 squared is 9. 9 times 4 is 36. 36 divided by 3 should give me 12 pi for that volume of the cone. 3 squared is 9. 9 times 9 is 81 pi for the volume of the cylinder. 3 cubed is 27. 27 times 2 is 54. And 54 divided by 3 is 18 pi. All together, add those suckers up. I believe we get 111 pi centimeters cubed. A little bit easier of a process for volume than it is surface area, but altogether I could combine any shapes I really wanted to into composite shapes. And I'm really hoping we walk through that process of, for surface area, what am I able to touch, what am I not able to touch? And then for volume, just split them up into their shapes, find their volumes, add them all together. You guys have a wonderful weekend, get some homework done, and I will see y'all on Monday. Bring me some questions from these worksheets.